Section 1.2 deals with the lengths of segments. So far we know that through any 2 points there's exactly one line, and on the drawing here I've drawn line AB. We can see out to the right here that the symbol for line AB are the letters A and B with a line symbol above it. You could also call that line BA, that's the same line. Segments have lengths, and that's what differs. One thing that differs them from lines, which go on forever. They have infinite lengths, but infinity is a little hard to measure. In black here we see segment AB. It's the part of line AB that starts at A, ends at B, and all the points in between. The symbol for segment AB are the letters A and B, or BA, with a bar above them, but no points for the arrows this time, showing that the segment has ends. Since segments have lengths, let's suppose we put a ruler on this guy and we measure that it's 4 centimeters. Or we just want to claim that it's 4 centimeters. Then in the drawing, if I would simply put a 4 and the centimeters between the letters A and B there, I would be showing you that the length of that segment is 4 centimeters. There's another way to accomplish the same thing. If I don't have the drawing, but I want to say that the length of segment AB is 4, length segment AB is 4. That's a lot to write. Our shortcut will just be to say AB equals 4. And you can put the centimeters in if you like. So this tells us that the length of segment AB, whether it's drawn or not, is 4 centimeters. So we have 3 different meanings for the letters A and B. At the top, with a line symbol above it, we're talking about line AB. In the middle, with the segment bar above it, we have segment AB. And at the bottom, with nothing above it, it means the length of the segment AB. Okay. We have a special name for segments that have the same length. Segments that have the same length are called congruent segments. The symbol for congruence is here. It's an equal sign with a little squiggly line above it, a tilde if you're a Spanish student. And I have shown here 2 segments with both have length 4. Segment AB has length 4 and BC has length 4. We can either say that AB equals CD, meaning the length of segment AB equals the length of segment CD, or using the new word congruent, we can claim that segment AB is congruent to segment CD. Notice when you use the congruent symbol, you throw the segment bars in. Now, sometimes, I'm going to erase those 4s. We don't know how long the segments are presently, or may not ever in the problem, but we'd like to show that those segments are in fact the same length. All we have to do is make the same number of marks across each one, called hash marks. So if you put 1 hash mark across each of AB and BC, you're telling the reader that segment AB is congruent to segment CD. Now you could use 1 on each, or you could use 2 on each, or any number as long as we have the same number of hash marks on each one. Okay, sometimes in geometry we take things that are really just normal, everyday life things, and once we put them in a geometry book, somehow it looks complicated. I live in Bloomington. I used to do a lot of driving to Indianapolis. So this is supposed to show the road from Bloomington to Indianapolis. B stands for Bloomington, I stands for Indianapolis, and in between we've got Martinsville. Now we can also regard these as being 3 points on a line. There are 3 segments there, the segment from Bloomington to Martinsville, segment BM, the segment from Martinsville to Indianapolis, that would be MI, and the segment from Bloomington to Indianapolis, which is the whole thing, would be BI. Let's suppose on the odometer, I check as I take my trip, and I find that it's 20 miles from Bloomington to Martinsville. And I find that it's 23 miles from Martinsville to Indianapolis. So the question I'd like to ask you is, how far is it from Bloomington to Indianapolis, or what is the total length of segment BI? You might pause me for a second and think about it. Okay, I suppose you've paused and I'm back here. Well, I think most of us would say that those two numbers ought to just be added together. That the length from Bloomington to Indianapolis ought to be 20 plus 23 equals 43 miles if the 20 and 23 are accurate. Okay, so just a common everyday thought, and that thought is the two parts add to the whole. And we're going to be using that concept over and over and over. It will sometimes be with segments, it will sometimes be with angles, but this little concept that if you have these two non-overlapping parts that together make up a whole unit, the two little parts have to add up to the whole thing. Okay. We're going to try to apply that here. On my first example, I've got the 3 points. Oops. Sorry. I've got the 3 points A, B, and C on a line. The length from A to B is 5 and B to C is 10. The problem is asking us for the length of segment AC. Well, it should simply be 5 plus 10 is 15. Again, the two parts add up to the whole thing. Now, on the next one, I know the whole distance is 12. I know one part is 8. We want the other part. Well, let me just put a variable here. Let's call it A for a second. Then what we would know if the two parts add up to the whole thing is that A plus 8 must be 12. That means that A, when I subtract 8 from both sides, will be 4. The length of segment XZ is 4. I've just used the idea the two parts add up to the whole thing again. Okay, in our bottom one, we see that the length of SU and the length of UT are the same, and the whole length is 16. Now, a lot of you can probably just do this in your head. You can say, well, if it's being divided into equal parts, half of 16 is 8, and you're exactly right. More formally, if you wanted to put a variable here, whatever variable you put on SU, let's call it X, you'd have the same variable on the other one because it's the same length. So you could simply say X plus X is 16, 2X is 16, X is 8. Of course, that's what we knew from the very start. So the algebra there maybe is a bit of overkill, but it's showing you can use exactly the same concept, the two parts add up to the whole thing, every single time. Okay, here's another problem. We've got segment NM with a point L between. We have that the length of NL is given as 5x. It's also shown on the diagram as being 5x. The length of LM is 3x, and it's shown on the diagram there. And the length of NM is 15. Okay, again, we're going to use the idea that the two parts add up to the whole thing. So our equation will be 5x plus 3x equals 15. That's 8x equals 15. X is 15 eighths. Okay, well, 15 eighths, not the greatest number in the world, but we'll live with it. That's what it is. Now, the problem might also ask you, how long is NL? Well, we know that NL is 5 times x. So it's 5 times 15 over 8, which means it is 75 over 8. Now, 75 over 8, let's see, 8 goes in there 9 times. 9 times 8 is 72, so we'd have 3/8 left. How could we find LM? Well, two ways. One, I could use that it's 3x. So it's 3 times that 15 over 8, which means that LM is 45 over 8. And 45 over 8 is 5 5/8. As a check, you could check and see if 9 3/8 plus 5 5/8 equals 15, and if you check, they do. One more problem of a similar type here. Again, the concept is still just the two parts add up to the whole thing. So, the two parts, 6x minus 5 plus 2x plus 3 has to equal 30. That would be 8x, combining the like terms on the left, minus 5 plus 3 is minus 2 equals 30. So 8x after adding 2 would be 32, and x will be 4. To find the length of each part, NL is 6x minus 5. So it's 6 times 4 minus 5. That's 24 minus 5. It's 19. Now, here's a quick way, if you were really confident about your 19, to find the length of LM. LM has to be 30 minus 19. It has to be 11. And you could check that 2 times 4 is 8 plus 3 is 11. This all works out. Okay, you have enough information now to do the problems that are in section 1-2.